down to a single date column there. Okay, so then the next step is kind of tidying up this data set. So remember, we want to get down to having one observation per row. Whereas right now, for each observation, that would be a lake and a date, we've got 3 rows of data because the different variables are all split among different rows here. And so we want to get that down to 1 row per observation. And so for this one, because we're starting with a data set in true long format, we want to use the pivot wider function to make this wider. And so ultimately we want those results, instead of in 1 column, we would like 1 column per variable. So we're going to widen that. Telling it that, remember, ID columns, these are what identify unique observations. So in this case, a lake name and a date. And then we need to tell it where the names for the columns will come from, and that's coming from this column, the CAS_RN here. And all of our data are coming from the results column. So when we do that, now we get a wider format data frame here, where we have 1 row per lake and date. And now we've got 3 new columns for our different variables there. So 1 column of data per variable. However, there was more data than this contained within the original data frame. So perhaps we want to know what the units were, since each of these different variables, while we have the results here, the units for each of these are different. And so it's possible to pull either names or values to create the new columns from more than just 1 column before. So you can see here that this time I want to tell it where we're pulling the values, so what we're filling the columns with, from both the result and the units columns. So now we get something like this, where we have 3 columns of results and 3 columns of units. Maybe that's not the most useful way to deal with this though, because as you can see, for each one of these variables, such as turbidity, it's likely that the units will be the same across all of these rows. So maybe we don't really need a full column describing all of those units for every single row. And so instead, maybe we want to pull the column names from 2 columns rather than the results coming from 2 columns. So you can see now where we're going to get the column names from. I'll pull that from 2, and we'll pull the data just from 1 column. So now we have 3 columns of results, but this time we've got the analyte name along with its units as our new column names here, which hopefully is a little bit more easy to deal with. So for these data, I thought perhaps instead of just knowing what the actual result was, perhaps we would be interested to know if that value then surpassed some perhaps detection limit or threshold. And so it's possible to then take column names from more than 1 column, as well as the data that we're filling those columns with from more than 1 column. And so we can just provide vectors for both of those, and then ultimately we get something wider like this. So we've got 3 columns of results, 3 columns telling us whether the detection limit was passed or not, and a little bit more unwieldy column names now. But the dplyr package in tidyr provides nice functions for cleaning up those column names if you'd like to do that as well. Okay. So while this data set from the ambient lake monitoring set really comes in long format, and so we would want to make those data wider, oftentimes you might get data from an open access data source that's very wide. So you have many columns that actually all contain the same type of data, and we need to collapse that down into a longer format. So for example, you might have a data set where you're measuring population trends over time, and so each column may be a different year, and the data within that column are all population data. And since those are all the same type population data, they should all be in the same column, and then years should be its own new column rather than column names. So since the original data set started in long format here, in order to go back to long format, what we're going to do is we're going to first start with a wide format of data here, where we've got 3 columns of our different variables, 1 observation or 1 row per observation. And now we need to lengthen this. And so the arguments for pivot longer are just a little bit different than pivot wider. So here we're going to tell it which columns are being pivoted to a longer format. So I'm telling it to take turbidity all the way through pH. And then we provide the name of the new column where those column headers will go and the name where the data will go. Which then gives us something like this, where we have one column with all of the old column names and one column with all of our results data. However, you can see maybe we didn't want a single column containing both analytes and units there, and so we are able to split those apart all within one line of code here. We can split those apart and create several different columns to correspond to our results values. So if we start with our wide format there, perhaps we want to split our analytes and our units into different columns there. And so what we can do is then we're just going to tell it we're splitting these apart, and then we just need to provide which character we're using to separate those data as we split it apart. And you can see now this has turned it back into roughly what the original data set was, with the analyte having their own column in the units, and then results in their own column. So we have several rows per unique observation here. Okay, so those are sort of the basics of changing between long and wide format data. And so then next I want to move on to the separate and unite columns, which are very handy for working with data or columns that might contain more than one piece of information that you would like to split apart or combine back together. So separate is for, of course, splitting a single column into multiple new ones. And so I want to point out as an example here where you may do this is within this project code column that we have here in the raw data set. You can see that there are two parts to this. And so the first part of that is sort of which sampling program this data point comes from. And the second part of that is sort of which sampling partner or organization collected that data point. So perhaps we wanted to separate those apart. So in this data set, they're all the same, but you could imagine a large data set where maybe there were several sampling programs in there and you only wanted to work with the data from one of them, or you only wanted to work with the data from one of the organizations collecting those data. So then we would separate those apart so that we could group those or filter those out and work with those individually. And so we would just use our separate, telling it which column we want to separate the data from, and giving it the name of the new columns that we want to separate that into, and providing the character at which point to break those apart. And so now you can see we have a new column for just our sampling program, a new column for which organization was collecting those data points. Alternatively, you can see in our sort of previously tidy data set, we have our regular date format and year, month, day. But it's possible maybe you only wanted to look at all of the data points coming from June from every lake. And so one way to easily get that would be to split apart that date format there. So what we can do is we can separate the date column into, in this case, you can split it into more than 3 new columns with our separator there. And now we quickly have a year, month, and day column quickly taken from our original date column there. And so you can then work with specific months or years or something easily in that format. However, in this case, date can often be a very useful variable to retain if you wanted to analyze something over time. And so simply by adding in this remove equals false argument to that function, we can retain the original column as well as all of the new columns that we've created, splitting apart those data. And so then the opposite of this would be unite, when we're taking data from multiple columns and combining that into a single new variable. And so for example, what I was going to do here was create a new variable for year and lake name together. And so this could be handy perhaps if you are creating faceted plots where you wanted to look at lakes and years together for several variables. And so you need a year lake variable altogether by which to facet those plots. And so what I've done is I've just altered the date format there. So this time we're telling it the name of the new column that we're going to unite those into. And then you just simply list all of the columns that are going to be united and provide the separator that you want to put in between each of those pieces of data. And so then we wind up with our new united column with our year, our separator, and our lake name. And so one use case that I think Unite happens to be very handy is for creating nice tables that you would then include in manuscripts, because we could do something like create a mean plus or minus standard deviation column all here where we're uniting those different values together, which would normally be kept separate in our data, except for when you want those in a final data table in a publication. So for this, I'm going to use a small set of data, and what I've done here is just created fake mean and standard deviation data that you can see there for each of those lakes. And so those are just fake numbers just for showing this. And then I'm rounding all of those to 2 decimal places just to make them a little bit easier to view. And then you can see we're going to unite those columns, giving it the name of the new column. So this is the Unicode for the plus or minus symbol. And we're going to be taking data from these 2 columns, provide it the separator. And so then we get a new column that looks like this with our mean plus or minus standard deviation, which could be handy in data output. Okay, so then I'm going to move on to the last section here, and then hopefully we'll have some time for questions at the end if anyone is interested. And so far the pivoting and the separate and unite are handy ways for reformatting data and kind of making the columns a little bit nicer for working with. And this last section here is a little bit different of a way of working with data, which we're going to move over to nested data frames, and hopefully these will be a little bit, or make a little bit more sense once we can see what these look like in R. But as I had said during the presentation at the beginning, what we're going to do is we're going to condense each group within a data frame down to a single row, where we create a new list column that actually contains an entire data frame in and of itself. So just briefly, this is just some pre-processing of the data to make it a little bit easier to work with. And so I provided some comments there so that you can see what those functions are doing if you would like. But I won't spend a bunch of time on them. Briefly, I'm just going to take a couple of the different analytes or variables here, just a few of the different columns to work with. And then here I rename them to make them a little bit easier to see, get rid of some unnecessary ones, and then I'm just going to work with a couple of lakes, because when you start working with nested data frames, if they become very, very large, they become computationally slower in R. So I'm just working with a few of them here for visualization purposes. So for example, what that looks like, we've got just our list of a few analytes per lake, a few columns we want to work with, and just 75 rows of data to work with here. Just a little bit easier to view when we do this. So the first thing we want to do is we want to create a grouped data frame, because if we don't have a grouping structure, then when we nest it, remember, everything gets reduced down to a single row. So this entire data frame will just be down to 1 row, and therefore we haven't really changed it from the starting data frame. So what we're going to do is we're going to group the data frame by lake name, and then we're going to nest it. And then we will remove the grouping structure since we don't need that. And so here you can really see what these nested data frames look like. You can see we've got 1 row per observation, and now we have a list column for our second column, where this list column for each row actually contains an entire data frame. And so when you click on that, you can see that data frame for that particular group. So if we wanted to look up at Clear Lake here in Iowa, we could click on that, and there is the entire data frame for Clear Lake, Iowa, nested right there. So that's what we get, 1 row per grouping variable, and then a list column. So you can see when we create these nested data frames, they nest the data frame in the format it was. And so we were starting off with long format data. And so I'm just going to simply rename that to data long here because I'm going to create a new list column of data frames that we're going to put into wide format. And so this here, dealing with nested data frames, is really where it's handy to use the map functions from the per package, which I won't go into depth here, but you can kind of see how these work here. And so what we're going to do is we're going to tell it to create a new column, which we're going to call data wide here within our nested data frame. And then we're going to map over this data long column here, and we're going to apply the function pivot wider to each of those individual data frames. And so now we're dealing with column names that occur within these nested data sets here, as you can see, sort of date and result, for example. And so now we look at our nested data frame, and you can see that we have two list columns going on there. We have our original nested data in long format, and now we have a second list column of our data in wide format. So you can see one row per date, and then all of the variables spread across as different columns. So now this makes it really easy if you want to do, or perhaps perform some calculations in long format and some calculations in wide format. Now those both exist there, all in this one nested data frame. So far, putting it into wide format is something we didn't actually need a nested data frame format to do. That was easy to apply to the original data set, but something like applying different models or custom functions to each of those data frames individually is really where this comes in handy, because, for example, the output of a model is very different and so wouldn't match up with your data frame, and so a nested structure really works or comes in handy there. So for example, I'm just going to run some simple linear models on these data, and what we're going to do is we're telling it to add columns that we're going to name chlorophyll N and chlorophyll P for nitrogen and phosphorus. We're telling it we're going to map across the data wide list column, and we're going to apply this linear model of chlorophyll A versus inorganic nitrogen and chlorophyll A versus soluble reactive phosphorus. So we're just going to run those two simple linear models across our nested data. And when we look at that, we still have our we still have our list columns of data here, but now you can see we've got our model results, which instead of data frames are these lists of all model outputs and coefficients contained within these lists here. And so now we want to view those model outputs. And so what we're going to do is we're going to tell it, this is a function from the dplyr package telling it we're just going to iterate across each of those row by row. And then the broom package and the function glance are a handy way of looking at tidy model outputs. And so what we're doing is we're glancing at that chlorophyll A versus nitrogen model. And you can see now we have the complete tidy model outputs for all of our 5 lakes, all contained there in one unique output. So it's a handy way to run models across a bunch of different data sets or data frames all at once and return those outputs all together rather than running them individually. So the same thing is our model output for our models of chlorophyll versus phosphorus in all these lakes. Okay, and so then of course the last thing to do here is unnesting these nested data frames. And so if we want to turn a nested data set back into a full regular data frame, so you've done some transformation, applied some functions, and now you want those outputs back into a regular data frame to work with. We're going to take our nested data frame. We're just going to select the columns that we want to work with. So we're going to select name because this was our grouping variable. You can see our grouping variable here, each lake name. When you look at one of these, you can see that lake name is not contained within that list column. So we want to retain that. Otherwise, when we unnest these, we won't be able to tell all these lakes apart. And then the columns that we want to unnest, and we're going to tell it to unnest those columns. And we get a full regular data frame back, just like this. If you don't select which names you want to unnest, so for example, we just tell it this and we want to unnest this particular list column, that's fine. But you can see then we still have a list column here from our long format data. And so if you don't want to have that, then you can just simply make sure it isn't selected and unnest only those columns that you do want to see. And so that's sort of what you wind up with for nested and unnested data frames. And I guess I will leave it there. And if anyone has any questions about any of the parts that we covered here or how to apply these to other situations, I'm happy to take any questions or go over anything further if anyone wants.
Thanks, that was great, Robert. That's awesome. I haven't used nesting before. I learned something new.
Find it very handy in certain cases.
Yeah, it definitely is. It definitely seems like it would. And yeah, it seems good. I also haven't gone into the map or like the per package for mapping, but so it's useful to see a little bit about how that works too. Thanks. Questions for Robert?
I can always take questions at another time, or if anyone wants all these, like I said, everything, the scripts and the data are all up on GitHub, so you could look through them a little bit further if you wanted to and see, review some of the comments on those.
Bob, I had a question that's not specific to tidyr, but maybe, I don't know, I used to have trouble with tibbles where if I imported a data frame that was the tibble, it would just throw errors hundreds of lines of code later.
Mm-hmm.
What's the deal with that?
So the way that tibbles work and data frames work is just a little bit different in the background and not in the user-facing side of R. And so you run into trouble, or I run into trouble when you use base R functions that are not capable of handling tibbles. And so tibble is just the tidyverse data frame format. And one way to quickly get around that is you just add the function as.data.frame.
Yeah, that's what I ended up doing.
Back and forth. Yep. So for example, the function plot in base R to make figures cannot handle tibbles, so you just have to convert back to a data frame. Yeah. That's how I found to get around it.
Yeah, most of my stuff is in base R things like all of geomorph doesn't do any tidyverse stuff, so I have to stay away from tibbles. I was just curious if other people had that issue.
Yep, I have.
Do you think that philosophically it's starting just to be two different languages? There's like a tidyverse language and a base R language that like are becoming less and less able to communicate?
Yeah, it would throw errors sometimes even when the tibble was nowhere close to being used anymore. It had been long since not part of, and I'd just run a random plot on some random data and it would still throw some errors because I had a tibble somewhere, and it was frustrating.
Yeah, I've definitely run into that with tibbles. And
it retains a lot of data in the background without telling you, and tibble is one of those. Another one is if you grouped your data frame and you forget to ungroup it, you can run into problems way later, and then you just have to go back and ungroup it, which is frustrating, but I guess just got to learn to figure those out.
Fair, I can do that.
I had a quick question, Bob.
Yeah.
Is there any limitations to or is there any rules of thumb for how many pipes you should put into a specific function? Should you try to minimize, or can you just, I assume if you throw in a bunch of them, there's more chance of screwing up somewhere and ruining the whole stream, but.
Yeah, I think, no, there's not a limit to how many you can do. As far as I know in the what's it called, R for Data Science book by Hadley Wickham, Hadley recommends not putting more than about 10 pipes into something all at once. And so I would suggest doing whatever you feel comfortable with, but the longer you make it, the harder it gets to troubleshoot where in the process something went wrong. And so especially also if I'm trying to learn new functions and get used to how something works, then I do very, very short ones consistently just rename this object the same thing over and over. And I tend to build longer ones as I get more comfortable with what the functions are doing. But there's no limit per se. It just could make it harder to diagnose where issues are being thrown.
Yeah, makes sense. Thanks.
There's some nice comments
Okay.
on Bob that you should check out. Any other questions from
Oh, I
folks?
haven't been looking. Oh, that's very kind. I hope it's handy.
Yeah, unless there's anything else. I did record this, but I didn't start until like 20 minutes in. I completely forgot. So the very beginning is missing, but I think we, got there as they're starting to go through the code, or I started partway through the beginning of the code. So
Fair enough.
we'll definitely share that if you want to re-record. Just kidding. I think it'll be fine. I think people can look at your PowerPoint and then go to the code and it'll be good. But yeah, thanks so much for leading this.
Yeah. Well, thanks for letting me. All right. Thanks all.
Thanks everyone. Have a good day.